So I've been doing some drawing, and I want to show you my rendition of the Philippines. Doesn't look so good, does it? Well, that's because this is a drawing of the Philippine region 30 million years ago. Now, just to orient you, this is China up here, Borneo right here, and the very top of New Guinea right here. Now, New Guinea is going to move north a little bit, Borneo to the east, China stays where it is. But over the course of 30 million years, all these islands in the middle are going to move in different directions and at different speeds, and they're going to come together to form what today looks like coherent archipelagos, even coherent land masses that today we call the Philippine Islands. Okay, so I put some arrows on these islands, and as you can see, it's a bit of a mess. Now, let's get the easy stuff out of the way. Like I said, Borneo moves east a little bit, and New Guinea moves north. And then these three islands in the middle here, they form the Indonesian island of Sulawesi. You've got a piece of the Bornean coastline that moves east, a piece of Australian continental material that's moving north, and then this line of volcanic islands that's moving north a little bit, and the three of them collide to form Sulawesi. Now, if we go way up north to the coastline of China, we see what becomes the Philippine island of Palawan and the Philippine island of Mindoro moving south. They're actually pieces of the Chinese coastline that move south when the South China Sea opens up. Luzon, the big island that has Manila on it, is already quite large at this time, and it just rotates a little bit and moves north. So a really important island for this expedition is the large southern island of the Philippines called Mindanao. Now, Mindanao is composed of two different pieces, one of which is this one way up here that's going to move south, and the other one is this large volcanic island out in the middle of the ocean that's moving north. The two of them collide and form today what is a large round piece that's the bulk of Mindanao, and then a peninsula on the western side called the Zamboanga Peninsula, and that derives from this piece. Now, the reason why we're interested in this island is because a very peculiar kind of daddy longlegs was collected there a few years ago, and it was collected from this particular terrain. Now, we know that this daddy longlegs doesn't like to cross large bodies of water. In fact, we really have no examples of them doing that anywhere in the world. So how did they get way over here? One hypothesis is that they actually got to here first when Zamboanga was connected to Borneo. Perhaps when sea levels were lower, or perhaps when Zamboanga was closer, these were actually one piece of land, and these particular daddy longlegs could have gotten onto here, moved down, and then gotten onto here when the two pieces of landmass collided. So what we're going to do on this expedition is see if we can find these particular daddy longlegs on Zamboanga. And if we do, and they're related to the ones over here in Borneo, it gives us evidence that they got to this piece of land by going from Borneo to here and then down to here. Here's the region today. And as you can see, New Guinea's moved north, Borneo's moved east a little bit, Palawan and Mindoro have come down from the Chinese coastline, and they now form a line of islands between Borneo and Luzon. And then here in the south is Mindanao all put together with the Zamboanga Peninsula on its western side. And what we're going to do is collect daddy longlegs from all these different islands and piece together their relationships. And this will provide an alternate or parallel line of evidence for what these land masses were doing a long time ago.